Hi friends and welcome back. Today we're going to be making connections among multiplication strategies. Let's get started. Let's read the word problem together. Write an equation for the area of each rectangle. Then find the sum of the two areas. Let's start with the information we do know. What information can we glean from this model? We can see the dimensions of the first rectangle is 8 units and 30 units. We also know that the side length of the second rectangle is 4 units. From this model, we can also see its other side length, although it isn't labeled, is the same length as the first rectangle. What is it that we need to find out? We need to find the sum of the two areas. Let's start with the first rectangle. What are the dimensions of the first rectangle again? 8 units and 30 units. And how can we determine its area? We can multiply 8 units and 30 units. Do this with me now. What's the area of the first rectangle? 240 square units. Great. Now we need to find the area of the second rectangle. We know one side length in our model is equal to 4 units. The other side length is equal in width to the first rectangle. So what is the width of the second rectangle? 8 units. Now that we know the dimensions of the second rectangle, go ahead and take a moment now to calculate its area. What's the area of the second rectangle? 32 square units. Next, we need to find the sum of the two areas. I'd like you to pause the video here to calculate the sum and be sure to include a statement. I'll see you back here in a bit. Welcome back. What's the area of the combined rectangles? When we add the two areas, the combined rectangles, the area is 272 square units. Before we move on, there is an extension to this problem. Read it with me now. Find a faster method for finding the area of the combined rectangles. We found the combined area already, but what is a faster method? Again, let's look at both rectangles. We can see that they both have a width of 8 units. Suppose we actually combined both rectangles together. They would still have a width of 8 units. But what would their combined length be? 30 plus 4 is 34. That would be their combined length. So the faster method to finding the area of the combined rectangles would be 8 times 34. Let's do this now. Ready? 4 ones times 8 is 32 ones. 8 times 3 tens is 24 tens plus 3 more tens is 27 tens. It also equals 272. Draw a rectangle with a width of 8 and a length of 200. How can we find this rectangle's area? we multiply 8 times 200, which equals 1,600. Let's write the area inside of this rectangle now. Think back to the previous problem that we just solved. Here we had two rectangles that also had a width of 8. Let's combine all three rectangles. This one and the two from the previous problem. Let's go ahead and draw that now. How can we find the area of all three rectangles together? Remember, in the last problem, we multiplied 8 times 4 and 8 times 30. So then I can multiply 8 times 200, and then we can add all of the sums together. Let's record that as one continuous addition problem on our papers. We can see that we're multiplying each section by a width of 8. So we could also write it like this. Let's now solve to find the area of the entire rectangle, starting with the largest rectangle. 8 times 200 is 1,600. 8 times 30 is 240. 8 times 4 is 32. Let's compare the partial products to our rectangular area model. 8 times 200 is 1,600. 8 times 30 is 240. 8 times 4 is 32. The area inside each rectangle is the same as each of the partial products. Let's now add the partial products. What is the product of 234 times 8? 1,872. We recorded the partial products, starting with the largest unit, the hundreds. I'm wondering, does the order of the partial products change the final product? Here's what I'd like you to do. I'd like you to pause the video here to solve 8 times 234 again, using partial products, but this time beginning with the smallest unit, the ones. I'll be here when you get back, and we'll compare our work. Welcome back. Take a moment to compare your work with mine. Here we can see the answer is still the same, 1,872. The order of the addends doesn't matter. That's the commutative property of addition. I can record the partial products using the smallest or the largest unit first. So this rectangle, the area model, is another way to represent the partial products in multiplication. The next problem that we're solving together is 316 times 4. How many hundreds, tens, and ones are in 316? 3 hundreds, 1 10, 6 ones. Let's draw an area model with a length of 3 hundreds, 1 10, 6 ones, and a width of 4. Do this with me now. How can we solve this problem using the area model? We're multiplying 4 times 3 hundreds, 1 10, 6 ones. Perhaps in another class you learned about distributive property. Whisper this phrase with me now. Distributive property. With the distributive property, we can break apart the large multiplication problem into smaller parts and still get the same product. In this case, we can multiply 4 times 300, 4 times 10, 4 times 6. Let's write out this equation. Let's begin. 4 times 3 hundreds is 12 hundreds, which we write in standard form as 1,200. 4 times 10 is 4 tens, which is 40. 4 times 6 ones is 24 ones, which we write as 24. Let's add the partial products now. What's the sum of the partial products? 1,264. Next, I'd like you to pause the video here to do two things. First, go ahead and solve 316 times 4 using the standard algorithm. Then, I'd like you to compare it to the area model. Be ready to discuss when you get back. Welcome back. Go ahead and take a moment now to compare your standard algorithm with mine. Here we can see that we solved using the standard algorithm and we got the same answer, 1,264. However, when we look at the area model, it doesn't show us how we can regroup 24 ones as 2 tens, 4 ones, whereas in the standard algorithm, it does. Since I have 24 ones here, I could regroup the 2 tens. When I do that, I'll have 2 tens that can move to the tens place here. And now I have 6 tens, or 60. And then here, I'll